Okay, so the last part of this review is graphing conic sections. So we are going to make sure that we identify all the important information, which is everything that they're telling us here, if it's a parabola, ellipse, or hyperbola. And then we'll graph our conic sections, make sure we're doing it correct, vertical or horizontal, and all that fun stuff. So when you see these, you guys need to know which one's which. If it's two squared fractions with a plus sign equal to 1, that is going to be an ellipse. And on top of this, I can also tell you that this ellipse is going to be horizontal because in an ellipse, remember that you're looking for the larger denominator to tell you the orientation. Okay. So let's see, I can find my center. So if it's an ellipse, we're going to state its center, which is opposite of what's with x, comma, opposite of what's with y. The vertices, which relate to my a value, well, underneath x squared is 64, so my a value is 8. So I'm going to add and subtract 8 to the x coordinate of my center because 64 was found underneath x, okay? So if I subtract 8, I get -3, -2. And if I add 8, I get 13, comma, -2. Okay. My co-vertices, that's the next thing. So I have my center, my vertices, my co-vertices rely on the b value, which is the square root of the number underneath the other variable, which in this case is 3. And I'm going to add and subtract that 3 to the y coordinate of my center. So I have 5, comma, -5, and 5, comma, 1. So I subtracted 3 and then added 3. And then the last thing they want us to identify, but I won't graph, are my foci. Remember the foci are the square root of your a squared, which is 64, minus b squared. Okay, you always do the opposite of the parent function sign in order to find your foci. So 64 minus 9 is how I get to 55. So the square root of 55 is nothing pretty. You do not have to simplify that anymore. Just write your foci as points. So foci are on what we call the major axis, which in this case, since it's horizontal, will be x. So my foci are 5 plus or minus the square root of 55, comma, -2. So now that I found all that information I can graph, let's see, x's are pretty much all positive except for 1, -3. My y's are all negative except for 1, -1. So it's pretty much going to look something like this. So let's see, I have 5, comma, -2. So I'm just going to be lazy since I have to go all the way to 13. Just call that 5 and this -2. There's my center. Then I'm going to have -3, comma, -2 as a vertex, and then 13, comma, -2. See, then I'm going to have 5, comma, -5 as a co-vertice, and 5, comma, 1 as another co-vertice, and that's how I get to my ellipse as shown. Okay, the next one is when you have two squared terms and you're subtracting. So if I have two squared terms and I'm subtracting, that is going to be a hyperbola. So I know that this is a hyperbola. Okay, and this time the bigger denominator does not matter. The bigger denominator is underneath x squared, but this is not horizontal, this is vertical, okay? For a hyperbola, it matters which variable is positive. That's how you tell the orientation. So the center, though, is still opposite of what's with x. So 8, comma, opposite of what's with y. Here's the center. My vertices based off my a value. So in this case, it's not the bigger number. It's underneath your orientation, which is y. So the square root of 16 is 4. So I'm going to add and subtract 4 from my y coordinate, right? This is vertical. This is underneath y, so it's changing the y coordinate. So I have 8, comma, -7 and 8, comma, 1. To add and subtract from your y coordinate. Okay, my foci. My foci are going to be c equals the square root. Now, since the original is minus, it's going to be a squared plus b squared. That's how you get the square root of 116. I'm not going to simplify that at all, and it's not pretty. So remember, foci, since it's vertical, get added and subtracted to the y coordinate. So it's 8 comma negative 3 plus or minus the square root of 116. Okay, and then I need my equations of my asymptotes. So my asymptotes, you take the y part of your center, just get rid of the squared. So it's going to be y plus 3 equals plus or minus. Then you do the slope. Remember, we talked about this a lot on this video already. Slope is rise over run. So rise deals with what's underneath y. Well, we're not going to use 16. We're going to use the square root of 16. So the rise equals square root of 16, which is 4, over the run, which is what's underneath the x. So square root of 100, which is 10. And you can simplify that to 2/5 if you want. It's just not required. And then you take your x coordinate from your center, just get rid of the squared, as x minus 8. Personally, before I graph this hyperbola, I think it's easier to find the dash mark for your rectangular box. So that way you don't have to count out this slope. So I'm going to go ahead and find that. So I find my dash mark, which relates to my b value. So the b value, since it's vertical, is going to be underneath x, which is 10. So I'm going to add and subtract 10 from my x coordinate, which would be negative 2 comma negative 3 and 18 comma negative 3. So that's going to help me graph my rectangular box. So I'm kind of out of space, but I'll just do the graph down here. So let's see, my x values are pretty much all positive except for that negative 2. So in my y values, pretty much all negative except for that 1. So kind of just like my ellipse here. Okay, so let's see, my center is at 8 comma negative 3. That's my center. 8 comma negative 7 is one of my vertices. 8 comma 1 is another vertex. To make my asymptotes, we don't have to graph the foci, but to make my asymptotes, I'm going to use my dash mark to help me. So at negative 2 comma negative 3, I have a dash mark. And at 18 comma negative 3, I have another dash mark. And that is what forms my rectangular box for my asymptotes. Because remember, once you have this rectangle, you just can connect corner to corner through the center to get your asymptotes graph. If you don't graph it this way, I will be looking for these 4 points to complete your asymptotes. You actually have to count out a rise of 4, run of 10 from your asymptote. Okay? And then where your vertices are, what create your hyperbola. So a parabola facing up and a parabola facing down. Okay, we're going to go ahead and stop there. We have 2 more problems to go through, so we'll pull this into one more video to finish up your review for your test tomorrow.